Alright, we were talking about simplifying square roots, using properties to simplify square roots. And we defined what a square root was and said that you're always supposed to have two of the answers. You're supposed to have a positive square root and a negative square root, and that positive one is called the principal square root. We did a little calculator investigation and we found that you can multiply two radicands together to simplify square roots, and you can divide them, but you cannot add and subtract them because that's not the same. So here are two properties that are going to help us simplify square roots. So we're saying that A and B are positive numbers, right? So the first one's a product property. I could take the square root of a product and I could break it up as two square roots. This goes either way. The way that we looked at it in the calculator was the square root of 3 times the square root of 2 was the same thing as the square root of 6. But it goes in the opposite direction. As a matter of fact, that's how we use it to simplify square roots. So if I have the square root of 18, I can break that apart as the square root of 9 times the square root of 2. And I'd want to do that because this number right here is a perfect square. And the square root of 9 is 3. So the square root of 18 and 3 square root of 2 are exactly the same thing. If you don't believe me, put it in your calculator and test it out. Okay, quotient property works exactly the same way, but we have a fraction within our square root. We can break that fraction up as two separate square roots and then take the square root of both of them. So as the example here, the square root of 2 over 25, break it up as the square root of 2 over the square root of 25. The square root of 2 stays the same, but the square root of 25 is 5. And this and that are exactly the same, but the square root of 2 over 5 is in simplest form. Okay. So whenever we go to simplify square roots, there's two things that we have to do. Okay. So the first one is that the radicand can't have a non-trivial perfect square factor. What that means, non-trivial means it can't be 1. Pull that pen back up. Not 1. So for example, the square root of 20 is not in simplest form because it has 4, which is a perfect square, as a factor of it. Okay, and the second one is you can't have square roots in the denominator if you have a fraction. So again, for example, if I have the square root of 5 on the bottom, 3 on the top, that thing is a no-no. So those two things. We have to factor out perfect squares, and you can't have square roots in the denominator. That's what it means to put it into simplest radical form. So to start us out, since we're talking about perfect squares, here let's look at this sequence. We got 1, 4, 9, 16 organized in this table here. Next one would be 25, and then 36, and then 49. I think most people know their perfect squares up to at least 12 square being 144. But I want you to try to memorize these things all the way up to 20, these perfect squares. Better you have them memorized, the easier it's going to be for you to simplify square roots, because then you'll recognize them. Oh, I see 324, that has 18, it's a perfect square, so the square root is 18. That kind of thing. Okay, so now let's talk about putting square roots in simplest radical form. So if I do an equation and I get 3 over 6 as an answer, it's perfectly acceptable. It's a fraction, but I'd like to put it in simplest form. I'd like to reduce that down to, say, 1/2. By factoring out or dividing out a common factor of 3. So we do something similar with perfect squares. The square root of 75 is not in simplest form. And the process to put it in simplest form also involves some factors, but these are perfect square factors. Okay, so you want to try to think, in this first method, you want to try to think of a perfect square that divides evenly into 75. So you think of that list that you have burned into your brain, and I think, oh, I think 25 goes into that. It goes into that 3 times. So I break that up as the square root of 25 times 3. And since that's a product within the square root, I can separate those two. And then finally, what is the square root of 25? It's 5. And the square root of 3 stays the same. So those two are exactly the same. The square root of 75 and 5 square root of 3. It's just that this last one down here is in simplest radical form. Again, if you don't believe me, put that in the calculator, hit enter, put this in the calculator, hit enter, and you'll see they're the same. Like magic. Okay, so here's the first method. Factor in a perfect square. It's dependent upon you remembering or memorizing this huge list of numbers, and maybe even a little bit more. Okay? The second one is just involving a factor tree, and this one's actually, it might be a little bit easier for some of you that don't have room in your brain to memorize perfect squares. Okay, so you want to make yourself a factor tree and look for pairs of factors. Any pair that you have is going to come out of that square root symbol as a single factor. Anything else has to stay inside of the square root. So let's take a look. Let's make a factor tree. I know 25 times 3 equals 70. Start again. 25 times 3 equals 75. Okay, 25, its factors are 5 and 5. And so I see that I've got a pair of 5s there. I usually circle those. I bring one of them out as a 5, and that square root of 3 that's all by itself, it has to stay within the radical sign. Okay, the reason why this thing works is because, or the reason why this method works, is that 5 times 5 is 5 squared. And what's the square root of 5 squared? It's 5. Okay, so now let's say, just for example, if you had another factor. What if we did the same kind of thing and we had a factor of, say, 2 out here? But it doesn't have a pair with it, so you would just go ahead and multiply those two together and you would have a 6 underneath the square root symbol. Okay? Or maybe you had another pair of factors. Maybe you had, let me go back and erase some of this. Maybe you had another 3. Well, this would also come out as a pair. The 3 would come out, the 5 would come out, you'd multiply those together and you'd have a total answer of a 15 on the outside. Okay, so those are some of the things that you'd be looking for. So I know that that completely confused some people, so let me get rid of that stuff. Okay, we're going to do this first one together, and then I want you to pause the video and finish off the rest yourself. Unpause it, see if you got your answers right. Okay? So this first one here, I can either do it with a factor tree, or I can think of a perfect square that divides evenly in it. And I'm looking at 12, and I know 4 goes evenly into it. Square root of 4 times the square root of 3. And the square root of 4 is just 2. Square root of 3 stays the same. So those two are equivalent. It's just the one I just circled is in simplest radical form. Okay, go ahead and finish off the rest of these after you pause the video, and then check to see if you got your answers right. Rowan is freaking out. Alright, let's check to see if you got those answers right. Take a look. Pause if you need to. I'm going to call your attention to a couple of these. Let's look at the square root of 32. Some of you might have tried this, like thinking square root of 4 times the square root of 8, and then simplifying that to 2 square root of 8. The only problem is the square root of 8 still has a factor of 4 in it. So that square root of 8 is square root of 4 times the square root of 2, which reduces to 2 square root of 2. If I have this 2 multiplied times that 2, that gives me the 4 that's out front.
Hi, Daddy.
Hi, Rowan.
What are you doing?
I'm doing a math video right now, so you need to be quiet, okay?
Why?
Okay, and the last one is the square root of 300x cubed. If you look at the work right up at the top, I did the number and the variable separately. The square root of 300 simplifies as 10 square root of 3, and I can do the same thing with variables, x to the 3rd power. Factors as x times x squared, and then x squared, x, and x. So I have 2 factors of x, one of those comes out, and then 1 stays on the inside. Okay, let's try a couple of these together. Square root of 27. I'm going to do the square root of 27 as I can factor out a perfect square because I know 9 goes into it 3 times. And the square root of 9 is 3. And square root of 3 I just bring down. You might ask yourself, well, how am I supposed to know when I'm finished? Well, look at the square root. Is there a perfect square that goes into it? If there's not, then you're done. Is there a fraction with a square root on the bottom? If there's not, then you're done. Okay, rather than multiplying these two things out together, I'm going to make a double factor tree here. This is 2 times 5, and this is 5 times 3. Notice I have a pair of 5s here, so one of those gets to come out, and the 2 times the 3, they don't have pairs, so they get to be multiplied together, and they're brought on the inside, so square root is 6. Okay. Here I've got a quotient on the inside of the square root, so I can break that up as the square root of 9 over the square root of 64 separately, and then take the square roots of the top and the bottom. I've got 3 over 8.
And how does it open?
I'll show you in just a minute, okay? One last one. Break this up again, square root of 11 over the square root of 25. And the square root of 11 doesn't simplify, but the square root of 25 is just 5. And that one now is in simplest radical form. Okay, I want you to try these problems. Go ahead and pause it, then hit unpause, check to see if you got your answers right. All right, check to see if you got those things right. How about that? Pause it if you need to. All right, one more on this first objective, and that is, well, this is an extension, some kind of challenge problems. Now we're not talking about square roots. On the first one, we're talking about cube roots, and on this next one, we're talking about fourth roots. So the cube roots, just like for the square root one, you're looking for a number. Pull up my pen. Pulling up a number that you have to cube to get this radical back. Okay, and there's no perfect cube for that. So what we want to do is we want to make ourselves a little factor tree here, like 2 times 12, 2 and 6, and 2 and 3. This time, instead of looking for pairs of 2's, we're going to look for triples. So I have 3 factors of 2. One of those gets to come out, so 2. And this 3 is all by itself, so cube root of 3. The reason why that works is because 2 times 2 times 2, 2 cubed, if I take the cube root of that, I get my 2 back. Okay, so over here, now we're looking for a number that you have to raise to the 4th power to get x back. So again, let's make a factor tree. It's even, so 2 goes into it 81 times, and that's 9 and 9. Each one of these are 3's, 3 and 3 and 3 and 3. And there I have my 4 3's. One of those gets to come out. 4th root of 2, that 2 has to stay in. Alright, check out the next video on Objective 2. Post your questions in the comment section, reply to questions that other people have asked, and I'll try to keep up with it too.